Dear student, welcome to my channel. Today, in continuation of the chapter surface area and volumes, I will start from question number 14 of class 10. So, in question number 14, it is given that a vessel is in the form of an inverted cone. Its height is 8 cm and the radius of its top, which is open, is 5 cm. It is filled with water up to the brim. When lead shots, each of which is a sphere of radius 0.5 cm, are dropped into the vessel, 1/4 of the water flows out. Find the number of lead shots dropped in the vessel. So you have to find the number of lead shots. Here I have drawn the figure. This is the inverted cone, conical vessel which is inverted, and this is the lead shot. And we have to find the number of lead shots, how many lead shots are dropped, so that 1/4 of the water kept in the vessel becomes flowed out, overflowed. So how we can do it? First of all, we'll find the volume of the cone, and then volume of the sphere, the lead shot, and then we'll write an equation. From equation, after solving, then we can find the number of lead shots. So let us start. We'll find the volume of the cone first. So we'll write the volume of the conical vessel equal. So the volume of the cone is 1/3 pi r square h. So we'll write 1/3 into 22/7 into r. So what is the radius given? The radius of its top is 5 cm. So here radius, that one is 5 cm, and height is given 8 cm. Here the height is 8 cm. So that one is the height, it is 8 cm. Now we will write 1/3 pi r square. It means 5 into 5 into h. So h is 8. So this is the volume of the conical vessel. We will give unit centimeter cube. Now we will find the volume of the sphere, the each of the spherical shot. So we write the volume of each lead shot equal. So what is the volume of the sphere? It is 4/3 pi r cube. So we'll write 4/3 into 22/7 into r. So radius is given here 0.5 centimeter. So that one is 0.5 centimeter. So we'll write here 0.5 into 0.5 into 0.5, 3 times, as it is r cube. So I have written 3 times. Now we can reduce it. 4/3 into 22/7 into 0.5, we can write 5/10 into 5/10 into 5/10. Then we can cut it. So here it is 2, here 1, and here it is 2, equal. We'll write 4/3 into 22/7 into, here numerator is 1 and the denominator is 8. 2 3 times multiplied, so it is 8. Now here also we can cut it, 1, and here it is 2, equal. So it is divisible. So no need to divide it. we can write it 1 by 6 into 22 by 7. Let it be like this so that we can cut it 22 by 7 and 22 by 7. So now we'll write let the number of lead shot be x. Let the number of lead shot be x. Then we'll write according to question. So what is the volume of each lead shot? So each lead shot is 1 by 6 into 22 by 7. So we'll write n into 22 by n into 22 by, we will write 42 as it is given, equal, here it is given 1/4 of the volume of the water is dropped. So we'll write 1 by 4 into 1 by 3 into 22 by 7 into 25 into 8. So we'll solve it now to find the value of x. This implies n equal, now we can see here it is 1 by 4 into 1 by 3 into 22 by 7 into 25 into 8 into, now that one. So after side change it will become reciprocal. So here will be 42 by 22. Now we'll cut 22 cancel, 7 and that one 6 times, then 4 to the 8 and here 3 to the 6. So that one, here 2 to the 4, 4 into 25 equal to 100. So we'll write now answer. Therefore the number of lead shot equal to 100. So this is the answer. So I hope you can understand. Now we'll start question number 15. In question number 15, it is given that a solid iron pole consists of a cylinder of height 220 centimeter and base diameter 24 centimeter, which is surmounted by another cylinder of height 60 centimeter and radius 8 centimeter. Find the mass of the pole given the 1 cubic centimeter of iron has approximately 8 gram mass. Mean the density of the iron is given, and also given that the value of pi equal to 3.14. Mean wherever we will use the pi, we have to use the value as 3.14. According to this question, I have drawn the figure as it is given two cylindrical part. So one is base and another one surmounted. So the surmounted one is the smaller one and the base one is bigger one, and the dimension also given as the height of the base cylinder is 220 centimeter and the diameter is 24 centimeter. From this diameter we can find the radius as 12 centimeter, and the surmounted one, the height is 60 centimeter and the radius I have not written here, so it is 8 centimeter. So now we will find, first of all we have to find the volume of the pole. So and then for mass we just multiplied with 8 to get the mass of the pole. So let us start. We can write first the volume of the pole equal, so both of these are cylindrical, so we know the volume of the cylinder is pi r square h, and the value of pi is 3.14. So we'll write 3.14 into, so we are now finding the lower one. So 3.14 pi r square. So r is 12. So we'll write 12 into 12 mean r square into h. So height is 220. So we'll write 220 plus, now the upper one. So it is also cylindrical. So we'll use pi r square h. So 3.14 into, here the r is 8 centimeter. So we'll write 8 into 8 into height is 60. So that one, only to simplify to get the volume. Now we'll use calculator. You can multiply yourself manually. For reducing the time, for saving the time, I am using calculator. So you can see here 3.14 into 12 into 12, we know 144. So 144, and then we'll multiply by 220 into 220 equal to 99475. So it is 99475.2 plus, now 3.14 into 8 at the 64 into 60. So it is 12057 12057.6 equal, now we'll add it, plus 99475 equal to 532.8 centimeter cube. So this is the volume of the pole. Now we'll find the mass. Therefore we can write, therefore the required mass of the pole equal, just we are going to multiply with 8. So 8 into 1,1532.8. So here we will write gram equal. So if we multiply it by 8, so it gives us 262.4 gram, and let us convert it into kilogram. So we'll divide by 1000. So we'll write 892.26. So approximately we'll write kg. So it will be kg, and here we'll write approx. So we'll write approx, as we have taken only up to 2 decimal places. So we'll write approx. So this is the answer. So I hope you can understand. Now we'll start question number 16. In question number 16, it is given that a solid consisting of a right circular cone of height 120 centimeter and radius 60 centimeter standing on a hemisphere of radius 60 centimeter is placed upright in a right circular cylinder full of water such that it touches the bottom. Find the volume of water left in the cylinder if the radius of the cylinder is 60 centimeter and its height is 180 centimeter. So from the question we can see that here the radius of the cylinder also 60, then the base radius of the conical part also 60 centimeter, and the radius of the hemispherical part also 60 centimeter. So these are equal, and the height of the cylinder is given 180 centimeter, and you can see the height of the conical part is 120, and the radius is 60. So if we add 120 and 60, so we are getting 180 centimeter. It means that the solid, that is which is combination of cone and hemisphere, it is just touches the upper part of the cylinder and also touches the lower part of the cylinder. So what we have to find? We have to find the water left in the cylinder. So water left in the cylinder, how we can find it? First of all, if we find the total volume of the cylinder, and then we'll find the volume of this solid and then to subtract it. So if we subtract it, then we'll get the volume of water which is left in the cylinder. So one by one we'll find it. So first of all, we'll find the volume of the cylinder. So we'll write the volume of the cylinder, volume of the cylinder equal. So what is the volume of the cylinder? It is pi r square h. So we'll write 22 by 7 into, what is the radius? It is 60. So 60 into 60 into height is 180. So it is 180 units cubic centimeter. So this is the volume of the cylinder. Now we'll find the volume of the solid which is inside the cylinder. So here also two parts, conical part and the hemispherical part. So we'll find it now. The volume of the solid, we'll write volume of the solid equal. So let us write the conical part first. So what is the volume of the cone? It is 1 by 3. It is 1 by 3 pi r square. So r is 60, r square into h. So height is 120. That 1 centimeter cube. So we'll write the unit together. Then we'll add the volume of the hemisphere also. So what is the volume of the hemisphere? So volume of the hemisphere is 2 by 3. It is 2 by 3 pi r cube. So r is 60. So 60 into 60 into 60. So this is the total volume of the solid. Now let us simplify it. We can see here many things are common. 22 by 7 also, 60, 60. Then here also we can get 160. So if we take 60, so 2 will left here. And here also you can see 2 by 3, 22 by 7, 60, 60 and 60 is there. So if we take common here 1 by 3 also, here also 1 by 3 is there. So 2 will left. So let us take the common 1 by 3 into 22 by 7 into, so 60 into 60 into, here also we'll take 60 common. So what will left there? You can see here 1 by 3 already taken common. So here 2 will left and here also 2 will left. So we'll here write 2 plus here also 2, 2, that one. So it will be 4 by 3 into 22 by 7 into 60 into 60 into 60 centimeter cube. So that volume, now we will subtract from that one to get the volume of water left in the cylinder. So I am removing now. Therefore, the volume of water left in the cylinder cylinder equal. So we'll write it first, 22 by 7 into 60 into 60 into 180 minus, now we'll write that one. So it is 4 by 3 into 22 by 7 into 60 into 60 into 60, that one, equal. Now here also we can take the common. You can see here 22 by 7 is there. So 22 by 7 into 60 into 60 into, here also we can write 60 into 3. So 60 is common. And we will give bracket. Then here will be only 3 minus. Then here will be, that part is taken common. So here will be 4 by 3, equal. Now let us multiply. Let us multiply. I am using the calculator. You can do it manually. So 60 into 60, 60 into 60 into 60 into 60 equal to 216,000 into 22. So it is 4752. It is 4752,000 divide 7 into. So here we will take 3 as LCM. So here will be 9 minus 4. So we can write directly 5, equal. Now let us multiply that one by 5 into 5 equal to 2376. It is 2376 0 0 0 0 divided by 21, equal. Now we have to divide it by 21. So we'll get 428 point. So we'll write up to 2 decimal. It is 57. So it is in cubic centimeter. So after this also you can write the answer, but if we want to convert it into meter cube, so we have to divide it by 10 lakh. So it will be 1131428.57 divide 12345 as we are converting into meter cube. So we have to divide it by 10 lakh. Why? Because we know that 1 meter equal to 100 centimeter. So here meter cube. So we have to multiply it by 3 times 100. So it gives 10 lakh. Now you can see here 6 zeros are there. So the decimal also shift left side by 6 decimal places. So 1, 2, 3, 4, 5, 6 mean the decimal will come here. So it will be 1.131 up to 3 decimal we can write meter cube, and here we will write approx. So this is the answer, and this is the volume of water left in the cylinder. Thank you all of you. I hope you can understand. So after this question, the surface area and volumes for class 10 is finished. Next day we will start surface area and volumes of class 9. Thank you.